Okay, now that we have reviewed how to solve systems by using elimination and substitution, we are ready to learn how to solve systems with three variables. So we're going to begin with x minus y plus z equals -1, x plus y plus 3z equals -3, and 2x minus y plus 2z equals 0. So to solve a system with three variables means that we're going to find the values for x, y, and z that make all three equations true. Now a good practice is to number the equations. So I'm going to number these ones. This one is equation number 1, this one is equation number 2, and this one is equation number 3. And we're going to be combining the equations to eliminate one of the variables. I'm going to start by combining equations 1 and 2. Why? Because by combining 1 and 2, I will be able to get rid of the variable y. So that's what I want to do, get rid of one of them. So it will be x minus y plus z equals -1, and x plus y plus 3z equals -3. So now I'm going to combine them. X plus x is 2x, z plus 3z is 4z equals -4. And I'm going to number this equation, equation number 4. Then I'm going to combine two other equations to get rid of y. So one of the equations is going to be used twice. So I have to combine, I'm going to combine 2 and 3, because that way I can get rid of y as well. So I'm going to combine 2 and 3. So it is x plus y plus 3z equals -3, and 2x minus y plus 2z equals 0. So we combine them. X plus 2x, 3x. Y minus y cancels out. 3z plus 2z is 5z equals -3. And I'm going to label this 5. So now I'm going to combine 4 and 5. So I have 2x plus 4z equals -4, and 3x plus 5z equals -3. Now to eliminate the variables, I'm going to have to perform operations on both number 4 and number 5. What I'm going to do is that I'm going to multiply the first equation by -3 and the second one by +2. And the reason I'm going to do this is because by performing these operations, when I multiply -3 times 2x, that's going to give me -6x. And when I multiply 2 times 3, I'm going to get +6x. So then when I combine them, I will be able to eliminate x. So let's do that. -3 times 2x is -6x. -3 times 4z is -12z. And -3 times -4 is +12. Now we have 2 times 3x is 6x. 2 times 5z is 10z. And I wrote here plus, I was supposed to write equal. My bad. Two times -3, -6. So then we combine them. -6x plus 6x, they cancel out, which is what I was saying before. -12z plus 10z is -2z. Remember, when the signs are different, you find the difference between the two numbers and you keep the sign of the higher number. 12 minus 6 is 6. We divide both sides by -2. So that's going to give us z equals -3. That's our first answer. Now we're going to go back to one of the equations, to one of the original ones, and change z with the value that we found, so we can find the values of the other two variables. Okay, so I'll do that with the equation number 1. I'll do it with 1 and 2. So right here, 1 and 2. So it's going to be x minus y plus z, which is -3, equals -1. And then the second one is going to be x plus y plus 3, z, which is -3, equals -3. So let's see what we have. We have x minus y. We're going to add 3 to both sides. So that's going to give us equals 3 minus 1 is 2. Down here we will have x plus y. 3 times -3 is 9. -9, I'm sorry. So we're going to add 9 to both sides. 9 minus 3 is going to be 6. I'm hoping I didn't go too fast there. Now we're going to combine these two. X plus x is 2x. -y plus y cancels out. 2 plus 6 is 8. We divide both sides by 2. So x equals 4. So we have our second variable. And now we're just going to find the third variable, which is the value of y. And I'm just going to plug in the value of x here. So that's going to be 4 plus y equals 6. I take away 4 from both sides. So y equals 2. So I have found the value for the three variables. So my answer is the value of x, which is 4, the value of y, which is 2, comma, the value of z, which is -3. So it's 4, 2, -3. So if you go back up here and you plug in the values of 4, 2, and -3, it is going to be true for all three equations. If it is not true for all three equations, then that means the answer is wrong. This is how you solve systems with three variables by elimination. I'm going to show you one example on how to solve systems of linear equations with three variables by substitution. Okay, so let me just erase all of this. That's the reason that it is so important that you get very familiar with elimination and substitution with two variables, because that is easier. That way, once you start doing it with three variables, it will be less difficult. Okay. Okay, so let's go over our second example, which is going to be x plus 2y plus 3z equals 6, y plus 2z equals 0, and z equals 2. Okay, so in this one is easier than the previous one. I can just go back and plug in the value of z on the second equation. So it's going to be y plus 2z, which I know is 2, equals 0. So y plus 2 times 2 is 4, equals 0. We subtract 4 from both sides. So y equals -4. And then we just need to find the value of x, which again is going to be easier because I already have the values of y and z, so I can just plug them in. So it will be x plus 2, the value of y, which is -4, plus 3 times the value of z, which is 2, equals 6. So that means that I have x minus 8, because 2 times negative 4 is negative 8, plus 3 times 2, which is 6, equals 6. Negative 8 plus 6 is negative 2, equals 6. And then we add 2 to both sides. So that gives me x equals 8. So I have found the value of all three variables. That means that the answer to this system is going to be 8, comma negative 4, comma 2. And again, we can go back and plug in the values here to make sure that it is true for all of them. And we're going to go ahead and do it. So I'm saying that x is 8. Let me use another color. I'm saying that x is 8 plus 2. I said y is negative 4 plus 3. And I'm saying that z is 2. And all of this is supposed to equal 6. Well, 2 times negative 4 is negative 8 plus 8. Well, they cancel. 3 times 2 is 6 equals 6. So yes, it is true. So now we're going to try on this one. Negative 4, because I'm saying that y is negative 4, plus 2, z, which is 2. 2 times 2, 4 minus 4, 0. So that is true. And on this one, there's really nothing that I need to try or test, because it was given to me. So that means, yes, this is a solution to the system of linear equations.